Good evening, my YouTube viewers. It's Crystal here. I'm just here this evening because I wanted to do another code review for you. And basically what I wanted to do is I wanted to show you how you can make your own classification data set just using numpy arrays. In the past, I have made classification data sets and regression data sets for that matter using sklearn, but it's nice to know how to make a data set using just numpy arrays. So that's what we're going to do in this code review. So in the code review, the first thing we're going to do is we're going to create our program, and I created my program in Google Colab, which is a free online Jupyter notebook. So I import my libraries, and I import numpy as np, and numpy is your numerical computation library that's going to create your numpy arrays. I'm going to import pandas as pd, and pandas is your data processing library that creates the data frame from the numpy matrix. I'm going to import matplotlib.pyplot as PLT, which is your graphics library, and it's going to plot the data points onto a graph. And then I'm going to import Seaborn as SNS, which is written on the back of matplotlib, and is also a graphics library that performs statistics as well. And in the program, I'm also going to import sklearn, which is Python's machine learning library. So after we have imported our libraries, what we're going to do is we're going to create our data set. So we're going to create a variable called height, and we're going to create that by making random numbers with 1.75 being the median, and it having a variance of 0.2, and it's going to have 10,000 rows, and it's going to be what shall we say, rounded to 2 decimal points. And then we're going to create a variable called weight, which again is a numpy rounded number, in 60.32 is going to be the mean, and it's going to have a variance of 15. And it's going to be 10,000 rows, and it's going to be rounded off to the 2 points, rounded off to 2 decimal points. And then we're going to calculate the BMI, which is the weight over the height squared, and it can also be a round as well. I didn't round it. But we can go ahead and round this as well, just to make it fall in line with the rest. So that's rounded off to 2 decimal points as well. And then what we're going to do is we're going to create our label. So your label is going to be a blank array and a blank list, and then we're going to put it in a for loop for I in range 10,000. If BMI is greater than 30, obese equals 1, else obese equals 0. Label.append obese, and then we check the length of label, and it's 10,000. So now what we're going to do is we're going to take the height, weight, BMI, and label, and we're going to stack those together using numpy. So np health equals np.column stack height, weight, BMI, label. And then so now we've got height, weight, BMI, label stacked together as a matrix. So we've got some statistics here. We're printing off the mean of the height, it's 1.75. printing off the median of the weight. It's 60.15, and we're going to talk about the mean of the BMI, which is 20.4. So 1.75 and 60, that's the mean and the median, and then we calculated the mean BMI as being 20.4. So now what we're going to do is we're going to count the label. So count label equals np.bin count label. So we're going to print the number of people who are not obese, and that's 9029. And we're going to print the number of people who are obese, and that's 971. And now what we're going to do is we're going to use Panda to convert the numpy matrix to a data frame, which I didn't really, strictly speaking, have to do that, but I was really running out of time, and I thought instead of trying to do everything as a numpy array, which is what I could have done, I decided just to convert it to a data frame because it's easier for me to work with data frames, and I was running out of time, so I decided to keep it this way. But so we've got the data frame of height, weight, BMI, and label. Now we're going to plot the examples. We're going to do that with Matplotlib, and we're going to make a scatter plot. And so you can see that part of the graph is yellow, which that equates to a 1, and then the other part of the graph is purple, and that equates to 0 because you had more people who were not obese than you did have obese people. Now what we're going to do is we're going to define our x and y. So the health, y equals health label, and x equals health, height, weight, BMI. And after we do that, then what we're going to do is we're going to split the x and y up into training and validation sets. And the training set is going to be 90%, and the validation set is going to be 10%. And we're going to split it up into x train, y train, x val, y val. And then what we're going to do is we're going to define our model. And in this instance, we're going to use linear regression. So the model equals linear regression, fit intercept equals false, and fit x train, y train. And it's going to print your model intercept and your model coefficient, which is what we did. So we didn't have a fit intercept, so the model intercept is false. But I intentionally made this where it had a bit of an error in it because I wanted to show you something. So after I've showed it to you, then we'll go back and do it without an error. And we had 99% accuracy on this model. And then we predicted on the model, and again with the validation set, and again we had 99% accuracy. So now what we're going to do is we're going to check our matrix. And so we had 908 zeros and no false zeros, and we had 87 ones and 5 false positives. And then we're going to check our scalar matrix. We're going to create a classification report, and you can see that the classification report still had a really good score, but it wasn't perfect. So you get your precision, your recall, your F1 score, and then your support. And then we're going to print errors. And see, that's what I wanted to show you. If you look at the way that we printed the errors, if you can see all the little yellow dots interspersed with the purple dots, then that means that those yellow dots are errors. So what I wanted to do, so I intentionally made it with errors so you could see the yellow dots. But what we're going to do now is we're going to say fit intercept equals true, C equals 1E1 by, and we're going to run it again. And you see that when we ran it again, we had 100%. But with 100%, you would not have seen the errors in yellow, and that's what I wanted to show you. I wanted to show you the errors in yellow. So I think that concludes this code review. This is the second code review I've done because the first code review I wasn't happy with the program, so I had to find another program so you can see this program and see how it works. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my video, and I plan to make more videos for you in the future.